5 by 7 piece of paper has squares of side length x cut from each of its corners, such that folding up the sides will create a box with no top. Find the value of x that maximizes the volume of the open top box. So step 1, draw a picture. 5 by 7 piece of paper. Ooh, what just happened? Okay. 5 by 7. And we're going to cut a little square out of each corner. Okay, so we're cutting those out. After we make the cuts, I'm going to erase the bit that's gone. So like this is gone now. But we have to remember that the 7 went all the way to the edge before we cut it, and the same with the 5. Okay, so these lengths that we cut out are all x's. So now what I'm going to do is along these little tabs, we're going to fold 90 degrees up to make a box. So imagine folding up those tabs 90 degrees and you make a box. The volume of the box is length times width times height. Now, this is the length, okay? Remember, it was 7, okay? It was 7, but we're going to take away x and another x to get this length. So 7 minus x gives the length of the box. So that's 7 minus 2x. And then this length, it was 5. The whole thing was 5, but we're going to take away an x and an x. So this length here is 5 minus 2x. And then the height of the box, after you make your folds, this x is going to be the height of the box. So the volume is 5 minus 2x times 7 minus 2x times x. And this is what we want to maximize. This is not a quadratic, which means there's no nice little formula for how to calculate its maximum. If you knew some calculus, you could do some analytic things and try to find the maximum without looking at a graph. But we don't know calculus yet, so we're just going to look at a graph of this thing in GeoGebra. Just type it in just like this, and your graph will look something like this. And this maximum is what you're looking for. And the command in GeoGebra is extremum. So you do extremum. You type in the name of your function. In this case, I called it v. And then you have to give an x-coordinate that's to the left of the maximum, and then an x-coordinate that's to the right of the maximum. So it looks like this is at about 1. So I could put in like 0 and 2. And it tells me that the coordinates of this point are 0.96, comma 15.02. So remember, this is x, this is volume. So they asked to find the value of x that maximizes volume. So the value of x is 0.96. That's what you were asked to find. The volume, the maximum volume you can get by building a box this way is 15.02. But that's not what we were asked for. We were asked for how big should we make the cut. So the answer is 0.96.